This is video 4 in our series. We used simple household material to collect carbon dioxide from alka-salt, so we measured its density. In our last video, we took a butane lighter and we actually measured the density or the molar mass, depending upon what the teacher wants to do. Today's experiment uses, again, simple household materials. And we're going to measure the heat of fusion of water. And the heat of fusion of water is actually a measure of how much heat is needed to melt ice. It's not a melting point in degrees, but it's the amount of joules. And joules is the energy unit now that we use. Joules took the place of calories. And it's simply a measure of how much heat does an ice cube have to absorb to melt. And if you went into a chemistry book, you would see that the heat of fusion of water is a standard, and it's locked into the number 334 joules, or heat units, for every gram for every degree. We're going to change it. So right now, using ice cubes, which I have in here, a styrofoam coffee cup, and a thermometer, we could actually verify the heat of fusion of water, which again, as I said, is a standard. So this is a nice experiment because we would be going into the laboratory and we would be measuring something that scientists already measured, and we would like to see how close we can get to an actual standard. This is called a constant. And this is in, as I said, it's in all the chemistry books. So we're going to start with a sample. We're going to actually weigh our styrofoam cup first, and this cup weighs 3.87 grams. If I weigh the cup, I could then determine the mass of the water that I'm going to put in, because that's one of the characteristics that I need, one of the things that I need to know. So if I have 3.87, all right, and I will write that down here, 3.87 grams. All right, I'm then going to use water that's been just slightly heated. I don't want to use water from the tap. I want to just bring it up a little bit. And right now, when I put that back, it weighs 222.48. So if I take 222.48 and subtract that, (218.61 grams of water, and that is going to be my starting point. Okay, I'm now going to measure the original temperature of this, because the temperature is going to go down. The water is going to absorb the temperature. All right, so when I keep the thermometer in, this is my second important number, which is the mass, which is the temperature of the water. So right now, it appears as if I'm at the 40-degree mark. Okay, so I have a mass of 218.61 grams, and my initial temperature is 40. Okay, I don't have to mass the ice, but I am going to mass it very quickly. The mass of the ice is 33.14 grams. I'm going to take that very quickly, and I'm going to put that into my water, and I'm going to stir. And I can see that the ice is absorbing the heat from the water. And therefore, if the ice is absorbing the water's heat, the temperature of the water is going to go down. And I'm going to wait till every piece of ice is melted. And when I do so, that is going to be my final temperature. and I can make sure all of this is done. Right now my last piece of ice has melted and my temperature has gone down to 29 degrees. That's my final temperature, 29 degrees. So, you are going to take, let me get a piece of paper here. I'm going to write everything down. You're going to take the mass of the water, okay, which in my case was 218.61 grams. You're going to multiply that by the temperature change, and in this case 40 and 29 is 11 degrees. And that's 11 degrees. And then you have to multiply that by the constant for water, which is 4.2. Okay, and then you're going to divide everything by the mass of the ice. And this is what it looks like. My mass of the water was before and after the cup, 218. My temperature change was 11. Since I'm using water to absorb the heat, I'm using water's specific heat capacity of 4.2 joules per gram. And then this was the mass of the ice that I used. I very quickly put it on the scale. And if I multiply, 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 and divide, I should get something close to the heat of fusion of water. This cup should be insulated. You should put a lid on it and punch a hole through it, because I'm losing heat to the environment right now. But I'm just giving you an overview of how you're going to do this in the classroom. So, ice cubes, scale, thermometer, coffee cup. First thing I need to know is how much water do I have in my cup? What's the temperature of that water? How much ice am I using? How much is the temperature of the ice? How is the ice lowering the temperature of the water? I take the mass of the water, I multiply that by the temperature change of the water, I multiply that by the constant for water, which is called its specific heat capacity, and I take that number and I divide it by the mass of the ice, and when I do all of that, I should have a number close to the 335 joules per gram, but maybe mine is going to be a little bit off because I'm not insulating my coffee cup, and this classroom is an air-conditioned room which is robbing it. A couple of trials and you will get exactly 335 joules per gram. And what you would have successfully done is taken an ice cube and melted and measured the heat of fusion of water, which is listed in any standard chemistry book, and which is a number that students have to use for other calculations. Your teacher will now continue with the lab.